Okay, hi guys. Okay, so this is the Algebra and Functions set 2. I hope this records okay, otherwise I will be re-recording them. Let's go through this. Okay, so I haven't worked through these yet. You're working through them with me for the first time. So hopefully, apologies in advance for any errors or if I go too fast. Okay, so let's have a look. We've got an equation. We've given that x plus 2 is a factor. So we're going to say x plus 2 equals 0. And if x plus 2 equals 0, x equals minus 2. And that's what we're going to substitute in. So we're going to say f of minus 2, we know must equal 0 because that's the factor theorem. So we're going to get 2 times minus 2 cubed minus 5 times minus 2 squared plus minus 2a plus a equals 0. And then we're going to clean that up. So we're going to get 2 cubed times 2 minus 2 squared minus 5. So we're going to end up with, if we move the a's onto the other side, we're just going to get a, and that's going to equal minus 36. Okay, so we get minus 36. Now we've got a functions question. We've got g of 5. So first step, we're going to start with the inside, and we're going to do g of 5. So we're going to substitute 5 in. So we get 2 times 5 equals 10, plus 5 is going to give us 15 on the top. And then we're going to have 5 minus 3 on the bottom, which is 2. So we've got 15 over 2, or 7.5. We're then going to substitute the 7.5 into the equation. So we're going to have 2 times 7.5 plus 5. So that's going to give us 20 on the top. And then 7.5 minus 3 to give us 4.5. You can stick that into your calculator if you don't feel like using your mental arithmetic, and you get 40 over 9. And then we've got the range of g. So if you saw the last one that we did, we talked about how we would find the asymptote of g. And in order to find the asymptote, the y asymptote, we're going to always divide through by x. So if we divide everything by x, our g of x becomes 2 plus 5 over x, 1 minus 3 over x. And as x gets bigger and bigger and bigger, both 5 over x and 3 over x go towards 0, because you divide by a bigger and bigger number, you get smaller and smaller, and your g over x tends to 2. So we know the asymptote is 2. We know we're starting at 5. We can plug 5 in, but we already did that, and we got our 7.5. So our range of g, the y must be bigger than 2, because that was the asymptote, and less than or equal to 15 over 2. And now we're going to find the inverse, stating its domain. So first of all, what we're going to do is we're going to make it y equals 2x plus 5, x minus 3. Swap our x's and y's. 2y plus 5, y minus 3, and rearrange to make y the subject of the formula. So when we rearrange it, we get x, y minus 3 equals 2y plus 5, xy minus 3x equals 2y plus 5. Move all the y's onto one side. Xy minus 3y equals 5 plus 3x. Take y outside the bracket. Equals 5 plus 3x. Sorry, it's going tiny in the corner here. And you end up with y equals 5 plus 3x over x minus 3. Is that right? That should really be a 2 at the bottom. Where have I gone wrong? So swap my x's and y's. Xy minus 3x equals 2y plus 5. Okay, I magically made it into a 3 here. Sorry, that should be a 2. The reason that I realized I'd done it wrong and that had to be a 2 was because my asymptote is 2. So my denominator has to equal 2. So you kind of, that's almost your sense check. Your domain is the same as your range of your original. So you're going to say, well, my domain must be x is greater than 2, less than or equal to 15 over 2. Okay. All right, so there's a question, and there's also how you fix a mistake, or the kind of sense checks that you can do as you go along. Right, let's have a look at the next question. I'm not quite sure what's happened here. All right, this has come out a little bit strange. I'm assuming it looks something like that. Okay, we'll ignore the point. So it tells us figure 6 shows a sketch of part of the curve. The point lies on the curve, find the value of A. Okay, so we're essentially making it equal to. So this is our x coordinate and this is our y coordinate. So we've got 96 root 2 equals 3 times 2a. Right, so the first thing I'm going to get rid of is I'm going to do 96 divided by 3. So I've got 32 root 2 equals 2 to the 2a. 32 we know is the same as what? So you know 32 is 2 to the power of 5. So we're going to put everything 2 to the power of 5. It's 2. 2 to the power of 5 times 2 to the half equals 2 to the 2a. So then we add those up. So we get 5 plus a half must equal 2a. So a must equal 11 over 4. And that would be your exact value. Okay. Next question. The curve 3 times 2 to the x meets the curve. Okay, I remember this question. Don't start logging things straight away. It's just an indices question. So you've got 3 times 2 to the x equals 15 minus 2 to the x plus 1. Like in the previous one, start off by putting things in terms of 2 to the x. So we're going to have 3 times 2 to the x equals 15 minus 2 to the x times by 2 to the 1. Right? So if you can see here, you've got 2 lots of 2 to the x on the right-hand side and 3 lots on the other. We could put them all onto one side. So we'll get 5 lots of 2 to the x equals 15. So 2 to the x equals 3. Now remember the thing that's to the power, this is your base. So straight away you can say x is log base 2 to the 3. So the way to remember is 3, 2 to the power of something equals that when you're converting it into logs. Okay, so question 5. Okay, a curve. Y-intercept, x plus 2, so find in the simple as fx. So we've got f dash x and we're going back to fx. So we're going to have to integrate. So f dash x means it's been differentiated. We're trying to go back to fx. So we're going to integrate it. Integrate, remember, add 1 to the power, divide by the new power. So fx is going to be 6x cubed over 3, which is 2x cubed. Ax squared divided by the new power, so 2, minus 23x plus c. Don't forget your plus c. But we're told the y-intercept is minus 12. So straight away, we know our plus c is minus 12. So fx equals 2x cubed plus a half, let's write it like that, ax squared, 23x minus 12. And now we know x plus 4 is a factor. So x plus 4 equals 0, giving us x equals minus 4. We can sub that in, make it equal to 0. And we therefore will be able to find our a. So if we plug that in, we get f of -4 equals 0, and sub that all into my calculator. So 2 times -4 cubed, 4 squared is 16. So okay, so let's just write it out. Plus a half a, you can put it all in one go. -23 -4 -12, and we know all that all equals 0. And that leaves us with a equals 6. So our final equation, so fx equals 2x cubed plus 3x squared minus 23x minus 12. Okay. Question 6 says calculate f2. Okay, so we're going to plug 2 in. F2. So we'll get 2 cubed, which is 8, times -3, so -24. 2 squared, 4 times 8, so plus 32, minus 18, plus 10, which equals 0. Okay, so it's helping us out there. We now know that x minus 2 or 2 minus x is a factor. It doesn't matter which way round you do it. So you'll end up either with a negative or you can take it the other way. So I'm going to write it as, so you've got 2 options. You can either say x minus 2 is a factor, at which point you'll get an answer that's minus something squared plus something and so on. Or you could say 2 minus x is a factor. Either way, it doesn't matter. And then we're going to do our division. So I'm going to take it as x minus 2, x minus 2, x minus 2. And I'm going to say, how do I get minus 3x cubed? What will I have to have outside the bracket? So I'll need minus 3x squared. If I open out that bracket, I've got minus 3x cubed plus 6x squared, but I want 8x squared, so I need a plus 2x here. So I get plus another 2x squared to give me the 8x minus 4x, but I want minus 9, so I need minus 5 here. So I get minus 5x plus 10. And so I can see my second bracket, because I've used the x minus 2, is going to be minus 3x squared plus 2x minus 5. And it just wants us 2 algebraic functions, so we're done. Okay, using your answer to part A, part 2, okay, prove that there are exactly 2 real solutions. Well, first of all, we need to work out how many solutions this will give us. So does that have any solutions? So you can plug it into b squared minus 4ac. You can sense check it on your calculator as well, and you'll see it doesn't have solutions, but you can also substitute it in. So you're going to say minus 3x squared plus 2x minus 5 equals 0. If we do b squared minus 4ac, we've got 2 squared minus 4 minus 3 minus 5. So we end up with minus 56, which is less than 0, so no real solutions. And then if we have a look here and we do a match up, we can say that x, so always just look for your x term, is the same as y squared. So we say if y squared equals 2, which we know is a solution, y equals plus or minus root 2, only 2 solutions. So that's the only 2 solutions that are possible. And now we've got it for tan, and we're doing tan between 7 pi and 10 pi. So it's only 1 mark. So you're like, okay, how many solutions could it be? So if we just think about a tan graph, we've got and we think about So this is pi by 2 and this is pi. So between, if we think about, we've got plus root 2 up there, for example, and minus root 2 there, between every single pi, you've got 2 solutions. So from 7 pi to 10 pi, so every pi by 2, 7 pi, 8 pi, 9 pi, 10 pi, you're only going to get 1 solution in each section of pi. So they're going to be 3 solutions. I hope that makes sense. So within every pi, you're going to get 1 solution. And if you're not sure about that, draw it out or even calculate it, but it's 1 mark. You could make a sensible guess there. Because remember, it repeats every 180. So tan repeats every 180, which is the same as pi. So therefore, if you've got 3 lots of pi, you're going to have 3 solutions. Okay. Question 7. Write fx in the form ax plus b plus c squared. So we're just completing the square. Like I said, you could just use your calculator, find the max and the min point. So if you go to your menu, your equation function, polynomial, stick your equation in. Here equals twice to go past the x1 and x2. It tells you the minimum is -1. So you can say, well, that's got to be that. And the y coordinate is 7. But you can also do it how you've learned to do completing the square. Take 2 outside the bracket. Complete the square for the bit in the middle. X plus 1 squared minus 1 plus 9. Open it out and you get the same answer. Okay, so we're going to sketch the graph. Well, we know the minimum point is -1, 7. So -1, 7, we've got a point there. We know it goes through 9. I always draw the 9 in afterwards, or the point, because otherwise my curve looks a bit strange. And that's it. Okay. Describe fully the transformation with this. Okay. So if you have a look at this and you're going to compare it to what you have in that initial equation. So if you have a look, instead of x here, we've got x minus 2. So we're like, okay, let's try that. We're going to replace the x here with x minus 2. So let's find out what f x minus 2 would be. X minus 2 squared, x minus 2 plus 9. So we'll get 2x minus 2 squared plus 4x minus 8 plus 9. And so that's going to give us 2x minus 2 squared plus 8, and then minus 9, minus 8 plus 9 is going to give us -1, plus 1 even. And we want to go from +1 to -3. So what we've done is we've taken f, we've shifted it 2 to the right, and then to go from +1, we've -4. So what's happened for g of x is we've translated the graph to -4. So remember, inside the bracket affects the x does the wrong thing, the x is shifted in the positive direction, and then the y's have shifted down. Find the range of the function. So let's write it in the completed the square form that we had. So hx equals 21 over, and this is kind of like the trig questions you do when you think about the maximum or minimum. So we're going to say, okay, so what is the range of this function? So the largest point, remember we had our graph where we had the minimum, but remember dividing by a smaller number is going to give you the maximum. So this, if you like, the maximum of hx is going to be 21 over 7. So your maximum value is going to be 3. And what's your minimum value? So you're going to say, what can you not? Whenever you've got anything like this, if I was dividing everything, can you see I've just got 21 on the top? So it's just going to be 0. My y asymptote is just going to be 0. Because if I was to divide everything through by x, I would get 21 over x 2x plus 4 plus 9 over x, but because as x goes to 0, the top goes to 0, the whole graph will go to 0. So that's the range of my functions. Right. So here we've got partial fractions. So partial fractions can be done in a variety of ways. You will either use long division to find your a, or you can equate coefficients, or you can substitute numbers in. It doesn't matter which way you do it, but I will show you how I would probably do it. I would make the denominator obviously the same. We get a multiplied by everything, b, well, minus 2x, and c, x minus 3. Now, I would do a bit of both. So I'd say 1 plus 11x minus 6x squared equals a. Now, I know there's only, I would equate the coefficient. Well, if I open that out, I'm going to get x minus 2x squared plus 3 plus 6x, right? So you're going to end up with minus 2x squared, and then you've got plus x plus 6, so plus 7x minus 3, right? So straight away, you can see that if you equate your coefficients, minus 2a equals minus 6. So a has to be 3, because that's your only x squared term. And then for your other terms, you could substitute numbers in. So say I substitute, let x equal 3. That's going to get rid of that bracket, and then if I put x equals 3 into my left-hand side, I'm going to get 1 plus 33 minus 6 times 3 squared. So I'm going to get minus 20. And then I'll have I'll have 3 times minus 2 plus 1. So I'm going to get minus 5b. And so I get b equals 4. And then I could substitute. I wouldn't actually put a fraction in. I just put any number in. So for example, I would put 0 in at this point. And when I stick 0 in, my left-hand side becomes 1. My right-hand side becomes, if 0 goes there, 0 goes there, I get minus 3a plus b minus 3c. I know what a and b are, so I've got minus 9 plus 4 minus 3c equals 1. So I get minus 3c equals 6, so c equals minus 2. So instead of getting yourself confused with a fraction, you can just put 0 in. I hope that makes sense. Okay, now we're going to prove that it's a decreasing function. So hopefully, however you do partial fractions, This is just sort of me doing it quickly. And now let's put the numbers in and see what we get. So we end up with, we said a was 3, b was 4, and c is minus 2. Okay. And now we want to prove that it's a decreasing function. So in order to prove increasing or decreasing, we want to differentiate. So if we call this fx, let's rewrite that as 3 plus 4 x minus 2 to the minus 1. And that's a minus 2, 1 minus 2x to the minus 1. Okay, so to differentiate, the 3 disappears. The minus 1 comes down, so we get minus 4. X minus 2 minus 2. That minus 1 comes down, so we get plus 2. 1 minus 2x to the minus 2, but we've got to times by the differential of the bracket as well. So we're going to multiply that whole thing also by minus 2. So now let's rearrange that so we can put it so we can see what we're doing. So 2 times minus 2 gives us minus 4. And then what we can see is it's this whole squared thing again. It comes up again and again and again. We know that x minus 2 squared and 1 minus 2x squared has to always be greater than or equal to 0. Now, if we're multiplying them by minus 4, that means f dash x is a negative over a positive, so it gives you a negative, minus, like, if you like, a 4, so minus, you've got another negative over a positive, which will always be less than 0. Therefore, it's decreasing. But by stating this, and maybe one more sentence, therefore it's always decreasing, you would get your full marks there. Okay, so let's have a look at the next question. Okay, sketch the curve. Right, I know everyone hates sketching curves, but don't think about that. Let's take it step by step. Think, what does 1 over x look like? Because that's a curve you should know. So we've got 1 over x, which looks like that. But here we haven't got, and that would be the same if it was 1 over 2x, 1 over 7x, it was 5 over x, whatever the case is. But now we've got a minus in front, which means it flips in the axes. So we now know if I had minus 1 over something x, it looks like this. Okay, where my asymptotes are x equals 0 and y equals 0. So that would be for this bit here. But then it's moved up by k. So instead of the y asymptote being y equals 0, the y asymptote now is going to be y equals k. And it's going to move up like that. Okay, so we've got a horizontal asymptote where y equals k, and it wants you to find this coordinate here where it cuts the axes. So where it cuts the axes, we know at that point there, y is 0. So 0 equals k minus 1 over 2x. 1 over 2x equals k. So x equals 1 over 2k. So this coordinate here would be 1 over 2k, 0. And then we're told we've got a range of values of k, and it cuts the graph in 2 places. So essentially, we're going to make these equal to each other. That's going to be equal to that, and we're going to solve it. So we've got k minus 1 over 2x equals 2x plus 3. Multiply everything by 2x is going to give me 2xk minus 1 equals 4x squared plus 6x. I'm going to put everything on one side. 4x squared plus 6x minus 6x even. No, we'll put them on that side. Okay, minus 2xk plus 1 equals 0. And I know it cuts in 2 distinct places. So I know b squared minus 4ac is greater than 0. So if I rewrite that with my x outside the bracket, I'll get 6 minus 2k plus 1. So my a equals 4, my b is 6 minus 2k, and my c is 1. And we're going to do b squared minus 4ac is greater than 0. So we're going to get 6 minus 2k squared minus 4 times 1 is bigger than 0. And we're going to solve that. If you've got your calculator solves your quadratics for you. So if I then solve that, I put that into my calculator, it tells me k is less than 1 and k is bigger than 5. They want it in set notation. So remember, that's when you do the squiggly brackets. And because it's 2 distinct areas, you do them as 2 squiggly brackets. Okay, hope that makes sense. Like I said, we're going to write these up, or I'm going to screenshot these, or you can screenshot these and work through them. We'll slowly do these a bit nicer, but I know some of you have assessments coming up. So the plan is to work through as many of these over the weekend. So by the end of the weekend, you should have them all done. Okay. Question 10. Oh, that's a bit weird. Okay, there we go. And this one as well. Right. State the range of f. Okay, so if I look at that graph, if it's telling me what's the range of f, the range is just the y's. So there's no maximum y. As far as we know, that graph keeps going up, but there is a minimum. And remember, it's like this is in the completed the square form. So we know that that point here is going to be 3, 5. So the minimum y is 5. So f of x is bigger than or equal to 5. And now we want to make it equal to a half x plus 30. So we're going to say 2, 3 minus x plus 5 equals a half x plus 30. Or this bit is negative. I'll put minus in front. The modulus bit. And you're going to solve them both. And you're only going to have one that gives you the answer bigger than or equal to 0. So your answer ends up coming out to be x equals 62 over 3. Okay, given that fx equals k is a constant, has 2 roots, find the set of possible values for k. Right, so what this is saying to you, so what this is saying to you is there's going to be a line that you're going to draw through like this. And when you draw it through, it's always going to have 2 points. So we can see that it's definitely not anything above this point here. Because if we draw a line at this point, we cross at 2, but anything above it isn't. So the first point we've got to work out is what's that value. So at that point is when x equals 0. So if we plug x equals 0 into our equation, we get 3 minus 0 is 0, that's positive, times 2 is 6, plus 5 is 11. So we know that k has to be less than or equal to 11. We also know that if it goes below or on this minimum point, it doesn't cross anywhere. So it's definitely not crossing twice. So that minimum point we know is 5. So we know it needs to be bigger than 5, but less than or equal to 11. So it can't equal 5 because at that point it only crosses at 5. That's the minimum point. It can't be, so it has to be bigger than that, but less than or equal to 11. Okay. Right. Last question. Oh, this is a nice question. Okay, we've got a negative quadratic and we're going to try find it. Remember, the minute we see a quadratic equation, if it's positive, we're thinking of our ax plus b squared plus c. If it's negative, we're thinking, so it's going to be one of those two forms. So if you think about it in terms of a completed the square form, you're normally given either a maximum point or a minimum point for you to be able to use that. So I'm looking at this graph and I'm going, okay, it's negative. So straight away I'm thinking of this. Instead of y, I've got h, and then I've still got x. So I've got h equals a minus b x plus c squared. And I'm going to see what I'm told. I'm given a maximum height of 12 meters and 40. So we know the h is 12 and this is 40. So that means I can substitute in my values. So I can straight away see that I'm going to have inside my completed the square form, if you like. I know that, and hits the, oh, sorry, I've read it wrong. Maximum height is 12. I should read the question better. And the final amount is 40. So because it's symmetrical, we can say that's 20. It's a quadratic graph, it's symmetrical. So we can say h equals 12 minus b, which we don't know. And here we've got x minus 20 squared. And then we know, let's just take the obvious, it goes through the origin. So if h is 0, x is 0, and that means we can find our value for b. And we rearrange that, gives us b equals 3 over 100. So h equals 12 minus 3 over 100, x minus 20 squared. And that's your quadratic equation. And then the next bit of the equation says the ball passes over a horizontal bar that's 3 meters above the ground. So this is when h is 3, what is x? That's all it's asking you to do, and it's asking you to solve that. But if you didn't get the first bit right, you'd have struggled to get this bit right. So 3 equals 12 minus 3 over 100, x minus 20 squared. So we would open that out, rearrange it, and you should end up with x equals 37.3 meters. Okay, so that's quite straightforward. And then the last question on this section says to give one limitation of the model. So a limitation of the model could be, what are we assuming? We're assuming it's a totally straight ground. The ball is a particle, there's no air resistance, anything like that. Anything sensible would have got you the mark. Okay, so I hope that's useful. I will keep doing more of these over the next couple of days. It's almost midnight, so I'm going to log off for today. But can you put in the comment section, so because obviously there is, wait, I downloaded all of them, I can tell you. There's like 10 of them, and differentiation is 2. So tell me which ones you want me to do first. So which topic test do you have first? And I'll make sure I do those in that order. Otherwise, I'll make sure I finish them by the end of the bank holiday, Monday. So yeah, and we'll look at the applied ones as well. I hope that's been useful. I will eventually clean these up, but for the moment, you've got them as they are. And yeah, thanks for watching.